Wondering how to assist the power transformer after being tested with T.T.R? Hi. Welcome to my channel. In this video, I am going to share with you my knowledge on how to assist the resulting value for power transformers after it was being tested on T.T.R, also known as the transformer turns ratio test. Also, I want to walk through some important notes on the transformer tap position value and some standards being used every time preventive maintenance is conducted. So without further ado, let's get started. In this video, we will show you how the correct approach when testing a power transformer. The first thing that you are going to find is the power transformer nameplates. Transformer nameplates contain several standard items of information and other optional information. Transformer nameplate must specify the following parameters: volt ampere VA or kilovolt amperes kVA rating, the voltage rating of both the primary and secondary circuits, the impedance rating of the transformer, normally restricted to 25 kVA or larger, the required clearances for transformers with ventilated openings, the amount and kind of insulating liquid where used. On dry-type transformers, no liquid coolant or insulation. The nameplate listing must also include the class temperature rating of the winding insulation. The nameplate always indicates the size of the transformer in terms of how much apparent power, rated kVA, it is designed to deliver to the load on a continuous basis. By its very nature, the transformer will have more than one rated voltage, depending on which side we are looking at and how many windings there are on that side. And since we only wanted to show you how to solve transformer turns ratio, we will consider the information of the voltage rating found at the nameplate. Looking at this example of the nameplate, we can tell the following parameters given, showing the exact specification of the power transformer. Especially in this side of the voltage rating. Talking about the tap position. Although power systems have a rated voltage, they often operate at voltages slightly above or below this voltage. This deviation from the rated voltage on the primary side of the transformer is seen on the secondary side of the transformer. Transformers are normally provided with taps to adjust the turns ratio to compensate for this supply variance. This will allow the output voltage to be closer to the rated output voltage when the input voltage is off rated voltage. Just like in this example, ratio tests are performed. Starts at finding the equivalent tap voltage rated ratio. Where as a result, just simply use the primary voltage divided by the secondary voltage. Primary voltage is the voltage applied to the terminals of the primary winding of a transformer. The energy applied to the primary must be in the form of a changing voltage which creates a constantly changing current in the primary, since only a changing magnetic field will produce a current in the secondary and exhibit a secondary voltage. And since this transformer is a three-phase power transformer, the resulting value is also divided by square root of 3. These are now our equivalent rated tap ratio, which means that these are values that we are going to use as reference for our tolerance. According to IEEE Standard C57.12.00-2006 factory test, the turn ratios between windings shall be such that with the transformer, at no load and with rated voltage on the winding with the least number of turns, the voltages of all other windings, and all tap connections shall be within 0.5% of the nameplate voltages. Unless the differences are greater than 0.5%, there is no cause for rejection of this transformer. Infrequently, it will be found that the ratio will be different from that specified on the transformer nameplate. This condition may occur when a very large transformer is equipped with a low voltage winding having a relatively small number of turns. In this case, the turn ratio should be expressed to the nearest complete turn. It should also be noted that transformers with load taps in the low voltage winding may not have an equal number of turns between taps due to the overall low number of turns in the low voltage winding. In such cases, the voltage variation with tap changer operation will not be uniform. All three phases should have the same measured ratio, although it may not be in exact agreement with the nameplate. And in getting those measured values, there are a lot of test set available on the market. It could be in the form of low voltage ratio measurements or high voltage ratio measurement. The instruments, when operated as described in the user manual, provide convenient and accurate readings of ratio and phase deviation of power transformers. So either, you are using the low or high voltage ratio measurement test set. The difference will provide more good results with power transformers as well as with potential transformers. When using higher voltage tests up to 12 kV that may be performed. In our test measure value appeared as followed. All are under the specified percent tolerance. Thus, the result does not appear to exceed the 0.5% tolerance, which means the power transformer are in good condition and up and running in service. And when it happens to fall greater than the said tolerance or the result is way from deviation, it is advisable not to put the equipment to service. Yet be mindful for further investigation and assessment on other supporting test procedure. Hope these will be helpful to you. And in your upcoming test to perform. See you on my next tutorial.